Really support the goals of what you're trying to accomplish here. And actually, I'm listening and learning a little bit to see how that would help even the Irish emerging community. So with that, and let me say on behalf of Intel, we're thrilled to host you guys here. It's amazing to see the bios of the speakers. I'm very impressed with the people that are going to be on stage after me, and I think you'll have a wonderful event here. So my goal here is to spend 30 minutes and just give you a brief but hopefully complete insight into what Intel sees with cloud computing. Now, cloud computing is a big term. I'm going to focus mainly on what the server end, the data center end of cloud computing, which is actually the part of it, the part that I actually work most with. My group designs the microprocessors that go into all of the Xeon and Canyon and also mic architectures which drive the backbone of the internet. So with that, let's just give a little insight into Intel. I'm sure everybody says they know about Intel, but not everybody knows the things that I'm going to mention. Clearly, yes, we're the largest semiconductor manufacturer in the world, leading manufacturer of computer, network, and comms products. We have over 300 facilities in 50 countries. Okay, now you can hear me, I guess. Over 40 billion in revenue, 24 consecutive quarters of positive of 24 years of positive net income. So we have not made a loss in 24 years. That's a huge accomplishment. We have over 95,000 employees, and lots of that employee base is technical. So groups like the CIE, are hugely important to Intel. Education is key to our future. We're one of the top 10 valuable brands, but things that people don't necessarily know about us, we invest over $100 million a year on education. That's teaching teachers, helping education in developing countries, and also here in the US. We're the single largest voluntary purchaser of green power in the US. And another item that I'm also personally very proud of, and I know our CEO is hugely proud of, is that employees of Intel have contributed over 3 million volunteer hours over the last 3 years worldwide. So I think Intel is not just a great company for making money for its shareholders and its employees, but it just delivers a huge positive benefit to society as well. Now, with that as a backdrop, what is Intel's vision for this decade? We're in 2010. This vision came out in 2011. This vision came out in 2010. And our vision is this decade we will create and extend computing technology to connect and enrich the lives of every person on Earth. And this is a very expansive vision. A very expansive vision because what you can see, and particularly as you see in China, but all over Asia, there are more and more people coming into the sort of developed economies. More and more people are able to buy and access technology, and more people's lives are impacted by technology, from education, which you would see in the upper left, to clean technology in the lower right. And we actually see that if you look at growth rates, if you look at how economies are growing, almost every single person on Earth is going to be touched by technology by the end of this decade. And that's an amazing transformation. I started this in this industry with Intel 21 years ago. I started in the industry 25 years ago. And just think, 25 years ago today, and then add another 10 years, and every single person on Earth is going to be touched by technology. And that's a huge opportunity for companies such as Intel. Within China, and this many people may know this here, but we're one of the largest multinationals in China. We've been there 25 years. We've over 20 offices in 17 cities. We garner or generate about $7 billion of our revenue, which is 16% of our worldwide revenue comes out of China. That's selling into the China local economy. We have about 8,500 employees, and we're very proud that for the last decade, we were awarded the Outstanding IT Company in China. We also have a big VC, venture fund. We have over $700 million that's allocated toward China, of which $500 million has been invested in over 100 Chinese companies. Those are Chinese companies in China, innovating for the China market, but also innovating for the worldwide market. And over 55% of our employees in China contribute to the volunteer service. So that's 3 million hours. over half our employee base in China contribute to that. So Intel has been with China for 25 years, and our presence is very strong there, and it's growing. So let's get to the core of what I think what's happening in cloud computing. So the first thing is Cisco published an interesting data point every year. And that data point is how much data in bytes cross the public internet every year. And remember, this is the public internet, which is what Cisco can track. And there's a lot of PhDs in the audience here, so I'll let you calculate how many zeros are in here and how to pronounce it. But you're looking at 150 exabytes of data through 2009. Now, I just want to pause on this data point. From the start of the internet through 2009, this is the amount of data that crossed the public internet. In 2010 alone, just in 2010, that data almost doubled. Okay? And you say, how can it double? Well, just look at the uses that you yourselves are doing. Video downloads, movie downloads, the size of files that people are sending. So yes, some of this is raw data, bigger files, but also some of it is new business models. And the thing to note here is just the rapid rate at which data is growing across the internet. Now, if you just look at that traffic, from that you can see, okay, what's driving it and what kind of opportunities come from it. By 2015, there could be over 1 billion people accessing the internet. There could be over 15 billion devices receiving or generating data into the internet with some very non-traditional uses. I'll give you one, and it's a funny one. In Holland, there's a product, and they attach a wireless device to each animal, each cow in the field, and a device can monitor what's happening with that cow, send the data back to a central place, and if there's any issue, then somebody can go out to that cow and see what they're doing, right? I know that sounds like a trivial application, but just think of the hundreds and hundreds of thousands of different applications that you can do with this. And the amount of data, again, is just growing exponentially. So within the next 5 years, be it devices for animals or the number of gadgets you have in your house or the different business models, the transformative business models that are happening right in front of us, that's generating this tremendous amount of traffic. And then where does that traffic be managed? Much of it, not all, but much of it is going into this cloud, and the cloud needs to be defined. What do we mean when we say it's all in the cloud? So Intel's vision, and honestly, I think this is an industry-wide vision for the cloud, is the cloud has 3 pieces. At the very bottom, we have all the different devices that will make up these 15 billion. Be it on the left-hand side, starting with desktop PCs and laptops. Just note, by the way, Intel sells over 1 million PC chips a day. Okay? And then you can go all the way to the right-hand side where you see your smart TVs and your embedded devices. And these devices are going to be all connected. So the idea being that conceptually you're doing something at home and maybe on your PC, on your TV, you may have a gadget, a smartphone, you'd like to download that data to the smartphone, you'd like to walk to your car and you'd like to put your smartphone into some sort of socket, and that same data is still available in the car. Okay? So that's a compute continuum of connected devices. All of these devices will connect into the internet, and that internet is going to be client aware. What I mean by that is, if you're deciding to download a Netflix video onto your high-definition TV at home, you might get one brand of service, but if you're trying to download it onto a small cell phone over a 3G or 4G network, you'll get a different service. So the internet will be client aware. It'll be aware of the device it's sending the data to. Now, in the internet, it tends to break into 2 kind of categories. Sorry, 3 categories. The one is the client aware, that's services that will customize themselves for the devices they're talking to. But there's also services, by the way, and companies represent this, and governments represent this, which we call as federated, and that is the data is protected. You can, in the US, you can imagine your health records, for example. A lot of health records are going to be automated. You want to make sure that they're protected, they're safe. If you move from San Francisco and you relocate over to New York and you want to move your health records from San Francisco to New York, you want to make sure that happens safely and securely. So there's a level of safety and security that's going to be needed as we share data across the cloud. And then you're going to have an automated cloud. One of the advantages of cloud computing is the ability to scale. You're going to want to be able to double, triple, quadruple your business depending on how you're doing. And that means that we need more and more of IT dollars, information technology dollars, to be spent innovating with new services and less on management. And what this means to a company like Intel is standardization. It means that most of the IT and data centers will want to standardize on a common architecture. They'll want to standardize on an open architecture that's very scalable. Today's data centers are often captive of technology that was there 10 or 15 years ago, legacy technology. So this vision of billions of devices connected to each other via the internet, and in the internet you have this cloud infrastructure that provides both security, that provides scalability, and is aware of the devices that it's talking to. This is what we believe the cloud of 2015 will look like. And at the core of that cloud, we think Intel architecture will be present. And we will have three architectures. The mainstream architecture of Xeon, which is by far the market leader and dominates. We also have a very high-end architecture for supercomputing called the Mike architecture. And then we have an Itanium architecture, which is a Unix-based architecture for mission-critical type of applications. Mission-critical includes things like stock exchanges, etc. So we have the solutions that we think are going to be at the center of this cloud vision. Now, if I take this to the data center, the cloud connects pretty much everything in the data center. I won't go through this in detail, but just to give you a sense as to of where do we see our products. The enterprise data center, that's the classic data center that many of your companies utilize. High performance computing, that's a huge, very visible and public, race to the top happening in the high performance and top 500 supercomputers. Cloud computing, the traditional folks that you think about in cloud computing are the Googles, the Apples, and so forth. Workstations. Workstations are where people do a lot of design. You can have a lot more 3D dimensional design being done on workstations. Small to medium-sized businesses. Now, by the way, cloud impacts these guys quite a bit because there's a lot of services that they can go to the cloud and just download onto a server, and that's going to cut the amount of money they need to spend to ramp up their business. Storage. Cloud computing means that there's more storage generated, but also there's more computing done on stuff stored. So if you take a video, for example, a movie in Netflix, and they want to download it to your house, then that goes through all sorts of encryption. And what they don't want to do is have to make multiple copies of that movie up in a data center, because that's going to explode the amount of storage they need. What they will want to do is they'll want to do all that encryption right where the video is actually stored. So that's bringing computing into storage products. Networking, the speed of the network and the ability to get information in and out of the cloud is becoming extremely important. So all around this circle, each of these segments is going to be impacted by the broader category of cloud computing. And again, Intel, we think, has products for each of these. Now, this slide, by the way, is interesting because most people will look at Intel, and depending on your TAM or which market you're looking at, you'll say, well, Intel has over 90% market share of the server microprocessor business. But if you actually look at the amount of money being spent in data centers, hardware and software, Intel's share of that is about 2%. So one of the things that excites me and excites us in our group is that we have a lot of opportunity to be able to grow within the data center. And if we look at what sort of disruptions are happening in the data center, cloud computing is one of the biggest disruptions. So as data centers standardize onto common hardware, as they try to standardize on new types of software, we think Intel has a range of products that would allow us to grow our footprint within this data center spend. Just a little history here. Our first server or data center product was in 1995. And I remember at the time, by the way, none of the big players, and there were many big players there, digital equipment was there, Fujitsu, Hitachi, IBM, HP all had their own products and solutions. We introduced our first product in 1995, and the Xeon brand came out in the year 2000. And from 1995 to from 2000 to 2010, the number of units, the number of microprocessors we sold to the market doubled. So in the last decade, our rate of growth in terms of the number of microprocessors we ship into data centers doubled. What's interesting is what happens in the next 5 years. In the next 5 years, we expect that's going to over double again. So last 10 years we doubled. We expect in the next 5 years we're going to grow by over double again. That gives you an indication of the acceleration that's going on in this data center business. There's a busy eye chart here, but this will give you a sense as to how the different markets are adjusting from 2010 to 2015. I'm just going to point to two segments of the market. If you go about maybe a third of the way down from the top, you'll see a kind of a gray color, and in 2010 that represented 10% of our unit shipments. In 2010, about 10% of our server microprocessors went into what would be called classic cloud computing applications. By 2015, that number will have doubled. So not only will the total number of units have doubled, but the percentage within that total going to cloud computing will have doubled, which basically means the cloud market is growing by 4x in the next 5 years. That's a tremendous clip. There aren't many markets that are growing at that rate. Networking, by the way, is growing even faster. 3% of our units go into networking applications right now. By 2015, 8% will. So that's almost that's a 6x growth in terms of the units that are being consumed. So cloud computing is absolutely a major driver for us. Two products we have, just to illustrate, what do we sell into the cloud? First is a Xeon microprocessor. It's a mainstream volume 1 to 2 socket. That's if you have a server, you open it up, you'll see 1 or 2 CPUs in it. And the type of things that our customers are looking for us are excellent energy efficiency. So that's the best performance for the best energy efficiency. So we would want to be able to show that we're much faster, 60% faster than our prior product, but we also have to say we have to do that at a lower power and energy. The types of applications that would run on this would be web apps, some core IT infrastructure, small to medium scale databases for those small to medium sized businesses. And you'll also see security features starting to show up, the importance of security showing in terms of this product. All of these things here are put into hardware. So obviously you can tell from this, we spent a lot of time studying what does the market need, and this is what the market needs in 2011. We have a second processor, which is for the most demanding workloads, and this is for the high end of the data center, and this is where reliability is very important, very large memory, scalability is important. And we're into large databases, employee ERP databases, business intelligence databases, and again, security becomes a very key component for this. I would say security, by the way, is probably the number one issue that CIOs highlight to us as they talk about computing over the next 3 to 5 years. So Intel's technology, always comes back to Moore's law. And the reason is, and we've got a graph here that's trying to illustrate, there was a little aside here that Gordon Moore saw this graph and said, wait a minute, that's not the graph I drew. I drew a different graph. But essentially what you'll see here on the y-axis, it's transistor leakage. So directly associate that to energy efficiency. And you'll see we've got our 65 nanometer technology, and then over time we're already transitioning down to a 14 nanometer technology. And what you see is we believe we have a very flexible technology that on the very low end will go into a smartphone, and we can use that same technology with some changes. There's some derivatives in there. And we can scale it all the way up to the fastest supercomputer. And that's something that I think we uniquely can do. We have the semiconductor technology, and we have the product design capability, and we have the go-to-market advantage that we can actually design a product, and then within 6 months we can scale it from a supercomputer all the way down to a smartphone. And that's an incredible capability that we bring, and our process technology is at the core of that advantage. So this takes us to 14 nanometers. This is a projected data. One of our speakers this afternoon, I know, is well aware of the trends in semiconductor technology over the next 10 years, but we absolutely have a roadmap of technology that extends for the next 10 years. So finally, let me just say what technology is one thing, but we need products that leverage that technology, and we have what's called a tick-tock model. If you think of a clock, you'll hear the second hand as it goes around. There's a tick-tock cadence in there. And we want the industry and we want the world to know that you just can rely on Intel's ability to deliver leading-edge products on a tick-tock cadence. A tock tends to be a very big microarchitectural transition, and a tick tends to be a change on the process leadership. So you'll see on 45 nanometers, we have a Penryn-Nehalem family of products, and then when we get to 32 nanometers, it's the Westmere and Sandy Bridge. So for servers, the second half of this year, we will launch the Sandy Bridge family of microprocessors. They'll go into production. And then you see our 22 nanometer products further out. So this cadence of products gives a predictable roadmap for our customers to run with. But it also says, when I laid out that vision of what the cloud will look like in 2015, I can assure you that we have products already under development that are targeting what that world looks like in 2015. So my group, and the last meeting I had yesterday was actually all around the products that we're going to be bringing to market in 2015. So I started the morning in what products get launched in the second half of this year, and I ended the day with what happens in 2015. Okay, and with that, I think that is my story for today. So I think I did good. All right, thank you very much.